Woo! What's up, party people? 3.5, Proving Lines Parallel. Welcome to your first installment. I'm up at Cispus right now, just tearing it up with the 7th graders in Loretta. Here we go. Proving Lines Parallel, 3.5. All right, you guys ready? Here we go. Whoa, dear. All right, let's start with a warm-up. All right, here we go. Write an equation of a line that passes through the points 8, -3, and -4, -12. Guys, my favorite equation form for linear equations is y equals m, where are you, mx plus b. M is the slope, b is the y-intercept. Let's find the slope. M equals y2 minus y1, rise over, that's our rise, right? Our change in rise, -12 minus -3, over our change in run, or our change in x, -4 minus 8, equals -9 over -12. No big deal there, and that simplifies to positive 3/4. That's our slope. Now let's use point slope formula, all right? With one of these points, we've got our slope, 3/4. Let's use this formula right here. Y minus y1 equals m times x minus x1. Sneak it in there. Excellent. x1 and y1, of course, are the x and y coordinates for one of our points. Let's use 8 and -3. Y minus y1 would be -3 equals our slope, 3/4 times the quantity, x minus 8. Okay? 8 from there, -3 from there. Let's go sideways. Y plus 3 equals 3/4 x. I'm distributing the 3/4 to the x minus 8, minus 3 times 8 is 24, divided by 4 is 6. All right, now I'm going to subtract 3 from each side, -3, and we have y equals 3/4 x minus 9. Easy peasy, right? Alrighty, next, warm-up number 2, write an equation of a line parallel to the line in question 1 that goes through the point 0, 2. Sylvia, this one's for you. Parallel lines have what in common? My bad. They have the slope in common. So we're going to take our slope from problem 1 and our point from problem 2. And you know what? You know what I'm noticing here? 0, 2. What kind of point is that? X equals 0? Well, that's the y-intercept. Y-intercept. We can just use slope-intercept form, okay? If we know that the slope is 3/4 and the y-intercept, that's b, that's our y-intercept in slope-intercept form. If we know b is 2, then we can just say y equals 3/4 x, 3/4 because they have the same slope, they're parallel, plus 2. That's our y-intercept right there, 2. Wow. Moving on. Proving lines are parallel. All right. So before, we were given lines are parallel, and then we used theorems like consecutive angle theorems. What else did we use? Alternate interior angles theorems. We used those to show that these angle pairs were either congruent or supplementary, something like that. In this lesson, we're given that the angles are congruent or supplementary, and then using converse theorems to show that lines are parallel. So we're given these relationships with the angles, and then showing from that lines are parallel. So recognize the angle relationships that occur when parallel lines are cut by a transversal. Use angle relationships to prove that the lines are parallel. No big deal there. Remember, what is the converse? For lack of a better term, let's just say the converse is opposite. Okay, or we're working backwards. Okay. If both the statement and its converse are true, that it can be written as a true, what? Conditional? Biconditional? Something like that. Conditional? I like that. Conditional, or is it biconditional? I don't know. We'll have to come back to that, okay? Let's see here. Converse of corresponding angles postulate. So here we go. If two lines are cut by a transversal, so here we have lines A and B. We don't know if they're parallel yet, okay? We don't. And they're cut by a transversal. Let's just label that T. So that corresponding angles are congruent. So we have 4 different pairs of corresponding angles. So corresponding angles lie on the same side of the transversal. So they're both above the transversal in this case. And let's see, and both, so corresponding angles are, in this case, for angles 1 and angle 3, those are corresponding angles, okay? They're both to the left of our 2 lines in question, so angles 1 and angle 3. If those are congruent, then our lines A and B are parallel. So lines A and B cut by transversal T so that angles 1 and angles 3, our corresponding angles are congruent, then we can say that lines A and B are parallel. Now that's different than our corresponding angles theorem, which says if 2 lines are parallel and they're cut by a transversal, then their corresponding angles must be congruent. In this case, we're starting with the fact that the angles are congruent, those corresponding angles are congruent, then in fact the lines must be parallel. All right, parallel postulate. If given a line and a point not on the line, so if given a line M and a point not on the line, P, there exists exactly one line that is parallel to M that passes through the given point, P. Once again, given a line M and a point not on the line, P, there exists exactly one line that is parallel to M that passes through that point. Okay, moving on. Proving lines are parallel. Okay, we've got alternate exterior angles converse. We don't know that these lines P and Q are parallel yet, but if the alternate exterior angles 1 and 3 that are created by this transversal, let's label it T, passing through lines P and Q, if these angles are congruent, these alternate exterior angles are congruent, then these lines P and Q must be parallel. We start with the fact that there are 2 lines P and Q and a transversal T, such that angles 1 and angle 3, alternate exterior angles, are congruent, then lines P and Q must be parallel. Moving on, consecutive interior angles converse. We're starting with the fact that we have 2 lines, P and Q, we don't know if they're parallel yet, cut by a transversal, T, such that consecutive interior angles 4 and 5 are supplementary, right? They're supplements of each other, you add them together and they equal 180, then lines P and Q must be parallel. Once again, lines P and Q, we don't know if they're parallel yet, are cut by a transversal T, such that consecutive interior angles 4 and 5 are supplementary, right? They add up to 180, then these lines must be parallel to each other. Okay, all right. Alternate interior angles converse. Given lines P and Q, and we don't know they're parallel yet, we're trying to show they're parallel, are cut by a transversal T, such that alternate, so those are angles that are on opposite sides of the transversal T, alternate interior angles, interior means they're enclosed within the lines P and Q, alternate, opposite sides, interior, within the lines P and Q. If they are congruent, then lines P and Q must be parallel. Okay, guys, hopefully you're seeing a theme here. We're trying to prove that lines are parallel based on angle relationships, okay? And perpendicular transversal converse. In a plane, if 2 lines are perpendicular, for instance, if line P is perpendicular to line R, that would be the transversal. If 2 lines are perpendicular to the same line, so if P and Q are perpendicular to this line right here, both perpendicular to this line right here, then P and Q must be parallel to each other. Or if P is perpendicular to R, and if Q is perpendicular to R, then P must be parallel to Q. Whew! Let's keep it going, guys. I'm working up a sweat. All right, here we go. Example 1. Given angle 1 is congruent to angle 3, what kind of angles are those? What kind of angles are those, guys? What's the angle relationship there? Angle 1 to angle 3. You guys know? What is it? All right. Those are corresponding angles, okay? Those are corresponding angles, all right? So if angle 1 and angle 3 are congruent, is it possible to prove that any of the lines shown are parallel? Absolutely it is, okay? So if lines A and B are cut by a transversal, so if lines A and B, are, oh my gosh, come on now, cut by a transversal, transversal, and what is that transversal? That's this guy right here, okay? That's our transversal. And corresponding angles are congruent. In this case, angle 1 is congruent to angle 3, then lines A and B are parallel. And what's the theorem? Corresponding angles, or converse of corresponding angles postulate. Is that it? Is that it? Converse of corresponding angles. Converse of corresponding angles. Boom. Okay. How about this one? Given the measure of angle 1 equals 103 degrees and the measure of angle 4 equals 100. So here's the measure of angle 1. Here's the measure of angle 4. Is it possible to prove that any of the lines shown are parallel? Well, if these two angles, measure of angle 1, or angle 1 and angle 4 were congruent, then we could show that angle A and angle C were parallel by the alternate interior, or the converse of alternate interior angles theorem. Okay? Is that a theorem or a postulate? Okay? Which is it? I got to consult my notes. They're theorems. All right. But since these guys aren't congruent, then we can't show that, okay? These angles, angle 1 and angle 4, aren't congruent, then we can't show that angle A and angle C are parallel using the converse of alternate interior angles, okay? All right, so no. Let's move on. Example 2, given angle 1 is congruent to angle 5. So there it is right there. Ooh, you guys see it? Angle 1 and angle 5. Is it possible to prove that any of the lines are parallel? And I'm just going to go ahead and say, if so, how? All right, so what kind of angles are those? What kind of angles are those? How are they related to each other, huh? What is that? Those are corresponding angles, right? Corresponding angles. We've got line L and line N cut by transversal P, okay? Lines L and N cut by transversal P. And if angle 1 is congruent to angle 5, then line L must be parallel to line N. Then line L must be parallel to line N. And the theorem we use is the converse of corresponding angles. Theorem. All right. Okay. Given the measure of angle 4 equals 105 and the measure of angle 5 equals 75, so here's 4 and here's 5. Is it possible to prove that any of the lines shown are parallel? What do you guys think? So angle 4 and angle 5. So first of all, what's the sum of those? Measure of angle 4 plus the measure of angle 5. And now I'm interested in the sum because I see that angle 4 and angle 5 are not congruent, right? Their measures are different. But if these guys can add up to 180, right, that would suggest they're supplements of each other, and then we're actually getting somewhere to prove that those lines M and N are parallel. So 105 plus 75 definitely equals 180 degrees. How convenient. Is it possible to prove that any of the lines shown are parallel? Yes, it sure is. So lines M and N cut by, let's erase that, by transversal P, such that, what kind of angles are these guys? Consecutive interior angles, such that consecutive interior angles are supplementary. Then, what can we say? What are we trying to show here? Is it possible to prove that any of the lines shown are parallel? Yes, then M is parallel to N. And that's by the, and I'll just say because converse of consecutive interior angles. Consecutive interior angles theorem. All right. You guys get it? You know, you can pause this at any time and to complete your notes, okay? Guys, you guys having fun yet? I am. I think this is pretty fun. I need some water, though. All right, here we go. I'm ready. All right, example 3. Find the measure of angle ZYN so that PQ is parallel to MN. All right, here's PQ, here's MN. So if we're finding the measure of angle ZYN, so here's ZYN, right? ZYN. So that these two lines are parallel to each other, then if these two lines are parallel, then we really need to say that PXW, angle PXW, PXW, XW is congruent to angle ZYN. Okay? And what kind of angles are those? Alternate exterior angles. Alternate because they lie on opposite sides of the transversal. So the transversal in this case is transversal, let's call it WZ. Okay, transversal WZ. Our angles are alternate exterior angles. Our alternate means opposite sides of our transversal. Okay, exterior means they're on the exterior of these two lines, PQ and MN, right? They're on the outside of the space kind of bound within these two lines, okay? They're exterior, alternate exterior. Those guys, if those guys are congruent, then we can say that lines PQ and MN are in fact parallel. So we're looking for the measure of angle ZYN. So let's just say that the measure of ZYN of angle or of PXW equals the measure of angle ZYN. Okay, definition of congruent angles. I'm just going to say that. Definition of congruent angles. Nice abbreviation. Thank you so much. All right, so now let's substitute ZYN, no, PXW. So let's see here. 11x minus 25 equals 7x plus 35. Let's subtract 7x from each side. Let's add 25 to each side. 4x equals 60. X equals 15. Is that really what I'm looking for, x? Well, that's the first part, but I'm actually looking for angle ZYN, or the measure of it. So I'm going to go ahead and substitute x, or 15 in for x, for ZYN. So the measure of angle ZYN, that's y, equals 7. Come on now. 7 times 15. We solve for x, right? Plus 35. 7 times 15 is what? That's 70 plus 35. That's 105 plus 35 equals 140 degrees. No big whoop, right? No big whoop. Doing it. Doing it. Okay. Let's move on, guys. Woo! It's a big one. Okay. All right, guys. You ready for this one? This one's a real doozy. Okay, here we go. We're given that line WX, that's this guy right here, is parallel to YZ. So let's just go ahead and do this, right? Let's just go ahead and say parallel. WX parallel to YZ. Please do that in your notes. And angle 2 is congruent to angle 3. Boom. Angle 2 is congruent to angle 3. All right, we're going to prove that WY is parallel to XZ. You guys ready? Okay. By now you're probably thinking, yeah, this is a parallelogram. Can't I just talk about the properties of a parallelogram? Well, we're trying to prove that this is actually a parallelogram by proving this other pair of parallel lines. Here we go. Let's start with so statements up here and reasons. I think I want to make this just a little bigger. Yeah, look at that. Woo! Okay, so 1 and 1. Statements. I'm not going to throw all the givens out there just yet, okay? I'm going to say WX is parallel to YZ, and that is a given, okay? WX parallel to YZ. We already drew it in. Okay, all right, let's do this. So remember, we're trying to show that these guys are parallel, okay? Let's talk about how we're going to show that. If we can show then that, so here we've got two parallel lines and we have two transversals, WY and XZ, okay? So this angle right here, XWY, and angle 3, these guys are supplements, and we're going to show that, okay? We're going to show that. Let's just do it right now. So the measure of angle XWY, measure of angle XWY plus the measure of angle 3, measure of angle 3 equals 180 degrees, okay? That's supposed to be a little plus. Dang. Whoops. Oh, look at it, came back. XWY plus the measure of angle 3 equals 180. And that is consecutive interior angles theorem. Consecutive interior angles theorem. Okay? So that's angle 3 and XWY. These are parallel lines. They're cut by a transversal WY, right? Cut by that transversal WY. And so these guys are supplementary. They're not congruent, but they're supplementary. They add up to 180, okay? And in the same way, okay, in the same way, the measure of angle 2 plus the measure of angle 4 equals 180. Measure of angle 2, angle 4. So in this case, we've got the same parallel lines that are given, WX and YZ, and they're cut by a different transversal, XZ, such that 2 and 4, angles 2 and 4, are supplementary. And that's also the consecutive interior angles theorem. Okay, so boom, 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 boom. Okay, whoops, and that would be number 3. Okay, all right, so number 4. If we can now show that, so let's just for a second pretend that we already know WY and XZ are parallel. That's what we're trying to prove. Then we could say that WX is a transversal. And if that's a transversal, if we could show that angle 2, right, and angle XWY are supplementary, then we could use the converse of consecutive interior angles to show that WY and XZ are parallel. Once again, if WY and XZ were parallel, then these guys, these consecutive interior angles, would in fact be supplementary or add up to 180. So if we can show that those guys add up to 180, then we can prove that WY and XZ are in fact parallel. And in that case, WX would be a transversal. So let's do that. Now let's use our other given, which is angle 2 is congruent to angle 3. Okay. Number 5. Let's do a little substitution here. Okay. If angle 2 is congruent to angle 3, and angle 2, the measure of angle 2 plus the measure of angle 4 is 180, then wait a minute, here, let's do this. Should we say angle 2 equals, let's just do it. Measure of angle 2 equals the measure of angle 3, definition of congruent angles. Okay. Now let's do a little substitution. Okay. Substitution, here it comes. Substitution property of equality. Then can't I say that we were talking XWY and angle 2 before. That'd be nice to show that those are complements, but let's do angle 3 and angle 4 because angle 3 is easier to write than XWY. So can't I substitute angle 3 in for angle 2 here? So the measure of angle 3 plus the measure of angle 4 equals 180 degrees by substitution, right? I'm dropping 3 in for 2 up here. Now wait a minute, if angle 3 and angle 4 are supplements of each other, then that must mean that WY is parallel to XZ, and that is with the converse of consecutive interior angles. Converse of consecutive interior angles theorem. Woo! That's a doozy, guys. That's pretty intense. So, once again, we're showing that. Now I'm just going to do this. Boom, boom, with the double parallel, okay? Those guys are parallel. We just proved it. We started off with our given. These two guys are parallel. All right, well, if those two guys are parallel and they're cut by a transversal, okay, then we can say that their consecutive interior angles are supplementary, okay? Angle XWY and angle 3 are supplementary. Okay, that's the consecutive interior angles theorem. And in the same way, we can also say if these guys are parallel, WX and YZ, and they're cut by a transversal XZ, that angle 2 and angle 4 are supplementary. Consecutive interior angles theorem. Now we know that angle 2 and angle 3 are congruent. That's part of our given. So now we're going to show that through the definition of congruence, if these are congruent, then the measures of those angles are the same. And if we know that the measure of angle 2 plus the measure of angle 4 equals 180, then we can substitute the measure of angle 3 in for the measure of angle 2 and say the measure of angle 3 plus the measure of angle 4 equals 180. Substitution. So if the measure of angle 3 and angle 4 are supplementary, right, or equals 180, then that means that WY and XZ must be parallel, and that's through the converse of consecutive angles theorem. We know that these guys are consecutive interior angles. We know that they are supplementary. So in fact, WY and XZ must be parallel. They're cut by this transversal. There it is, guys. Hey, that was a lot of fun. Tune in again for the next one, okay? Here's your assignment.